Dynamic Host Configuration Protocol, and it's all about computer networks. It describes how devices connect to a network and how a network's addresses can be configured and managed centrally. Let's say you buy a shiny new computer and want to connect it to the internet to watch your favorite YouTube videos. To join a network, a device has to have an IP address, an Internet Protocol address, on that network. There are two critical ways to achieve this. You can configure your new computer with an IP address manually, or you can let a DHCP server hand out an IP address to your computer. In this client-server interaction, a server manages a pool of available addresses, and new devices on the network, called clients or hosts, request an address to connect to the network. For home network setups, the DHCP server is often implemented as a service built into your router. So here's the process. You connect to the network with a cable or over Wi-Fi, your computer requests a unique address, and your router responds if it's configured to do so. To connect to the network, your computer leases an IP address from the server. This implies that your IP address will expire after a predetermined amount of time before needing to be renewed. Once your lease expires, your computer will request the same IP address from your DHCP server, which will decide whether to grant a request, assign a new address, or deny the request altogether. There are also ways in different operating systems to manually release and request a renewed IP address. Along with an assigned IP address that uniquely identifies your new computer, the DHCP server sends network configuration details to your computer to facilitate the connection. These details include the network address, subnet mask, default gateway, DNS addresses, and the lease period. Alongside DHCP leases, which are the dynamic part of Dynamic Host Configuration Protocol, IP addresses can be set up on a DHCP server to statically assign the same IP address to the same device every time. These are called reservations. Network designers and administrators typically use static IP assignment for servers and network equipment to ensure that they're always accessible. On the server side of DHCP, IP addresses are tracked in relation to the host's MAC or Media Access Control address. This Layer 2 address uniquely identifies the hardware attached to a device, which allows it to connect to the network, called a network interface or network interface card, also called NIC. There can be multiple DHCP servers on a network. This can be useful for failover if one server stops working, for load balancing to ensure that no single server is inundated with an unreasonable amount of requests, and for a variety of other reasons. On larger networks, DHCP servers may be a part of a router or firewall, or they may be physical or virtual machines that provide DHCP and perhaps other services, such as DNS. Wrapping it all up, DHCP is a mechanism that allows hosts to connect to a network with dynamic IP address leases or static IP address reservations, and allows network administrators to manage new hosts centrally.